Greetings and welcome, internet friends. Mr. Waddy here. We've already done the first three example problems from 1.4 in Algebra 2, but I just wanted to do some additional practice if you just want to see how these things are done, and if familiarity with this process will, build over time just through exposure of how to do these things. So here it's from the practice 1.4a. I'm just going to do a couple of problems today, maybe three. We'll see. So between these first three terms, 1, 2, and 3, the least common multiple is 6. Between 6, 3, and 4, the least common multiple is 12. And between 2, 1, 1, it's 2. So I'm going to choose to go for opposite z's for these. And so I'm going to call this equation A, B, and C. And so equation A already has a 2z. So I've got to figure out for equation B, what would I multiply this by to get the 2? Well, I'd have to multiply by 2. So I'll figure out what's 2b equal to. And to get this to equal a negative 2z, I'd multiply by 2. And so 2 Bravo, 2 Charlie. So 2 times 2x is 4x, 2 times negative 3y is negative 6y, 2 times z is plus 2z, equals 2 times 4, which is 8. And so yeah, don't forget to multiply the right-hand side of this as well. 2 times 3x is 6x. Blah. 2 times 4y is 8y, and minus 2z equals negative 4. Boom! And so now I'm going to eliminate the z twice in 2 different combinations of equations. And so only 2c has the negative, and so I'll have to combine it with this one to eliminate, and then again with this one to eliminate. So I'm going to do a plus, let's see, give myself some space here. A plus 2c, so 1x and 6x is 7x. Negative 6y and 8y is 2y. The z's cancel out as we were hoping, and then 5 and negative 4 combine to be 1. Boom. Then I'll do these two can combine to eliminate. So 2b plus 2c. And when I combine those, 4x and 6x is 10x. The y's become 2y. And the z's eliminate. And 8 and negative 4 combine to be 4. And so I typically call these equations D and E. And what's nice about them is that I have 2 equations with 2 variables, and it's the same 2 variables, right? They're both x's and y's, or they would have been both y's and z's, or x's and z's. You want to eliminate, as I did, the same variable twice in order to get the remaining 2. Boom. And so now I can solve this using my old school tactics, which I'm going to continue with the elimination method. So between 7 and 10, 70 is the least common multiple. Between these, 2 is the least common multiple. And so I'm going to get opposite z's here. Both of them already have the 2's. I just need to make one of them negative. And so I'll just do negative 1e, or opposite e. I don't know. What do you want? What do you want from me? So let's see. Negative 10x minus 2y equals negative 4. And so then I can combine d with this, and these y's will eliminate. So d minus 1e, 7x and negative 10x is a negative 3x. The y's cancel out conveniently. 1 and negative 4 is negative 3. And now I can solve this one variable equation using regular algebra. And it looks like I get x equals 1. That is only part of my ordered triple. And so now I'll throw this into substitute into any of these 3 equations, had 2 variables. I'll plug it into the first one, equation D, it looks like would be a good choice. And I just chose it because it had small numbers. So 7x plus 2y equals 1. I'm plugging in 1 for 7. 7 plus 2y equals 1. Subtract 7, both sides. 2y equals negative 6. Div 2, div 2. And I get y equals negative 3. And so now that I have x and y, I can solve for z. And so any of these 5 equations had all 3 variables. I'm going to plug it into the easiest one, which looks like this one, because it's just a plain old 1z. But it doesn't matter which one you do. I'm going to plug this in for x. I'm going to plug this in for y. My little box disappeared. There you go. So 2x minus 3y plus z equals 4. And I was substituting 1 for x, negative 3 for y. So that's 2 plus 9 plus z equals 4. 11 plus z equals 4. And I get, subtract 11 from both sides. And I get z equals, what's that, negative 7. And so there you go. My ordered triple is 1, negative 3, negative 7. Make sure you just write it in alphabetic order. Alphabetic order. Boom, boom, boom. All right. Looks like I've got another one. And so once again, they're suggesting elimination method here. Tell you what. I'm going to do maybe just the setup here for this one, and then I'll do substitution on the last one. So 1, 3, and 2. Least common multiple is 6. 4, 12, 4 is 12. 3, 9, and 4. 3 goes into 9, 9 and 4. 36? Yeah, is the least common multiple. So I'm going to go for opposite x's there. So I'd multiply, what would I need to do? I'd multiply the top equation by, I guess I could make that one the negative. That doesn't matter. I'll make it positive. So I would have done 6 times a. This one I would have multiplied by negative 2. And this one I would have multiplied by negative 3. And then I would have, combined and gone from there. So let's see. Let's talk about substitution method, which you don't have to use substitution method, but notice in a problem like this, it's all right. Let me go back to that statement. Even on tonight's homework, when it says use substitution method, if you used elimination, that's fine. I'm a fan. Go for it. Because I've already determined that you can do substitution in 2 variable stuff. You're fine. But why would I choose substitution method in this problem rather than elimination method? Well, notice I've already got one of the variables solved for. Another reason why maybe you would do that is you would target any time there was a variable with a positive 1 coefficient. Those are very substitutable problems. But here we go. I've already got this by itself, and so I would just plug in this for y here, and I substitute into both of the other equations when doing substitution, and that's gonna be very helpful. It'll get rid of the y in both of them, giving me 2 variables, 2 equations, etc. So let's see, x minus 2 times y plus z. I'm realizing like it'll be convenient to. Oh, no. Yeah, I'm wondering whether to write my next equation here or here. Not a big deal, really. Let me finish substituting it in this one first, I guess. Negative 3. So I'd have 2x minus 3 equals 5. And I'll solve for x. 2x equals 8. Now, it's possible I could have had 2 variables and 2 unknowns in both equations, and then I would have just solved by substitution or elimination. But here I happen to get fully being able to solve, like there was no z in that equation. and so I didn't have to do the dub subs. But here, looks like I could plug in for x and plug in for y, solve for z. Yeah. So x minus 2 times y plus z equals 6. X was 4, y was negative 3. So I get 4 plus 6 plus z equals 6. 10 plus z equals 6. Subtract 10, subtract 10. And z equals negative 4. And so substitution problems, if you have a problem where one of the variables is already solved for, or if it's an easy to solve for variable, it's got a coefficient of 1 or negative 1, you're welcome to use substitution and then dub subs, double sub, sort of thing from there. So the order triple is x, y, z. Boom. There you go. All right. Well, thanks for watching, internet friends. Have a great day. There was a little bit of extra practice for you if you wanted it. Adios.